This should be a quick video. Now that we're done with the review for Chapter 8, we're going to actually start getting into what Chapter 8's about, which is all about chemical reactions. Now, chemical reactions, what they do is they tell us what reactants and products are in a chemical reaction. They tell us what goes in and what comes out. So what things are changing. Now, there's some requirements for a chemical reaction. They show all the reactants and products. They show everything that's involved. They have the correct formulas of reactants and products. That's why we spent time in the last video reviewing how to balance ionic formulas, how to write out covalent compounds, to make sure that when you are writing out chemical reactions that you know how to write out the formulas correctly. At the end of the chapter, you'll have to predict products and write out your own formulas to finish the chemical reactions. That's our ultimate goal at the end of this chapter. Then the last one, the law of conservation of mass must be satisfied. That'll be right away next video. We'll learn how to balance reactions, which should be review from 9th grade a little bit, but we'll do a video on that and show you how to do that next video. Now, what we mean by the law of conservation, that means that the mass that goes in must be equal to the mass that comes out, or the number of atoms that goes into the reactions is equal to the number of atoms that comes out of the reaction. And then just a refresher, remember the reactants are the things that go in, the products are the things that come out of a reaction. So reactants, if we're talking, I always use my cooking analogy. You're baking a cake. The sugar, flour, butter, everything that goes into making a cake would be, the ingredients would be the reactants. After you heat it, a chemical reaction is happening, and then out comes the product, which would be a cake. So make sure you know those two words, what reactant and product mean. So if I say, what are the reactants? You know which side of the arrow I'm talking about. So there's two types of equations. There's a word equation that just represents the reactants and products by words or by the names of the formulas. This is not very common though. So an example would be like methane plus oxygen goes to carbon dioxide plus water. You'll see this occasionally, like in a biology textbook when you look at like photosynthesis or cellular respiration. Where they'll say sugar plus oxygen goes to carbon dioxide plus water, or for photosynthesis, carbon dioxide plus water goes to sugar plus oxygen. So that's basically it. But when you start getting into chemistry and chemistry textbooks, most often they use formulas and not word equations. The other thing, this isn't balanced, and there's not really any way to balance this without writing out the formulas. So that's why we're going to get to formula equations. These are much more common. They represent the reactants and products by their chemical formulas instead of their names. This is a lot more useful, and that's why it's more common. So this is the same equation that you saw on the last slide. This is the formula equation of the methane plus oxygen goes to carbon dioxide plus water. So in this you can see that it isn't balanced. It's easier to see that. You may not notice it right away, but there's 4 hydrogens on this side and only 2 hydrogens on this side. So this is not balanced because the amount of hydrogens going in does not equal the amount of hydrogens coming out. So that's why we'll learn how to fix that next video. So here's the same reaction as a formula equation. Also with the molecular structure, the pictures of the molecules, so you can see CH4 right here. You got the carbon plus 4 hydrogens, and you can see that you can fix the 4 hydrogen problem or the 2 hydrogen problem over here by adding another water molecule. So what happens is that 2 water molecules comes out of this reaction, and it actually takes 2 oxygen molecules going in. So it's not just 1 methane, 1 oxygen. It's 1 methane plus 2 oxygen goes to 2 carbon dioxide plus 2 water. So this is what we're going to learn, is how to add these coefficients to balance the reaction next video. And then don't forget, these would be called the reactants. So if I say, what are the reactants? You would say CH4 and O2. Then the products are CO2 and H2O. Now there's some common symbols you need to know, just so that you don't get tripped up on them when you see them on worksheets, tests, quizzes, things like that. The symbols, the first one and the obvious one is the arrow. The arrow means the reaction goes one way. It's telling you there's a chemical reaction. These compounds turn into, so compounds on this side turn into compounds on this side. It yields the things on this side of the arrow. There are such things as two-way arrows in chemistry. We do not deal with them in Gen Chem, but you would in college chemistry if you choose to take that course. These are reversible reactions, and the math and the complication of them gets very, very fun to deal with, in my opinion. Equilibrium is a very, what's the word I'm looking for? You'll see it a lot in chemistry as you move on. Equilibrium is a big concept that comes up over and over. There's a word I'm trying to think of. I can't think of it though. Now, if you see S, L, and G, don't freak out if you see those after the compounds. It just means solid, liquid, or gas. What's the state of matter? And then there's another one, AQ, which stands for aqueous. It means the compound is dissolved in water. It's in solution. So if you see the S, L, G, or AQ after the formulas in an equation, that just tells you what state it's in. Is it a solid, liquid, gas, or dissolved? If you add heat to a reaction, there's three ways to indicate that. You can just put the word heat above the arrow. Otherwise, this triangle also means heat. This is far more common than seeing the word heat in my experience anyways. Or if something needs to be run at a very specific temperature, you will see the specific temperature listed above the arrow. So all three of these mean that heat was added to the reaction. It's also possible, I should add, you might see 0 degrees Celsius here, so that doesn't necessarily mean heat is added. It could mean that it's run in an ice bath, actually. So 0 degrees Celsius would be an option there as well. That means that the reaction was run in an ice bath. Okay, if you see a formula above the arrow, don't freak out. That just means a catalyst was added, and a catalyst is simply something that speeds up the reaction. It's not consumed itself, so the catalyst itself is not consumed in the reaction, so it doesn't turn into something new. It just helps speed it up. PPT is another one. That just means precipitate. That means it's a solid that formed in the reaction. If you add pressure to if you run the reaction under higher pressure, you'll see the word pressure there. Or you'll even see like a specific value, maybe like 2 atm, like 2 atmospheres of pressure, or a certain PSI value, whatever unit is chosen. Now this last one is new to you. If you see a compound with a dot H2O, we call that a hydrate. It means that water is trapped in the crystal structure. We'll talk about that more in class. But just know that if you see dot H2O, we call that a hydrate. That's all you need to know at this point. So an example would be like CuSO4.5H2O. So this is an ionic compound. It has a crystal structure. So you think of the crystal lattice structure, and then trapped within that structure is a lot of little water molecules. So those water molecules are part of the crystal structure. Okay, the next video we're going to talk about balancing reactions. So that's where I'm going to end this video. Make sure you understand what the reactants are, the products are, and then you know all of these symbols for the reaction so you don't get surprised when you come across them.